1.2 is graphs of functions. We need to first talk about what a complete graph is. Even if you're using a graphing calculator, this applies. A graph is a complete graph if it shows the basic shape of the graph and important points on the graph. This includes points where the graph crosses the axes and points where the graph turns. And it also suggests what the unseen portions of the graph will be. For example, if you have a parabola, some kind of a parabola function, and you graph that, this is going to be a complete graph because we know that's as interesting as it gets. The part that's going off the screen, you just know it continues in that manner. Now, if you had a graph of a parabola and it was something like this, and this part up here was off screen, that would not be a complete graph. Or if you were graphing by hand and you did not plot these points up here, that's not complete. Those are important points, those intercepts, x and y intercepts. So that's one example of a complete versus an incomplete graph. So let's try our hand at graphing just by plotting points. I'm going to go ahead and make a t-table, an xy t-table. They want us to draw the graph using integer values for x from between -3 to +3, and put that into the equation. So we have y equals x squared. If we put the -3 in for the x, it's going to be y equals -3 squared. The parentheses placement is very important. If you don't have the parentheses there, this will end up being a -9. You can even try that on your calculator and see that that's true. But this will be a +9. -3 squared means -3 times -3, which is a +9. And if we used a -2, same way, -2 squared is +4. -1 squared, we'll get a +1 out. And 0 squared is 0. And just finish this out and get those values put in 0, 1, 4, 9. You can see the symmetry in your graph there. That's nice to see on a parabola. And let's go ahead and graph -3 to 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Now this is not a scatter plot. We did graph these 7 points, but there are infinitely points in between these 2 points and infinitely many points between those 2 points and so on. So we go ahead and sketch in that graph between those points so that we can see the shape of the graph, and if we did graph more points, they would be on that curve. So that is that's our graph of the equation y equals x squared. Now if I want to make a complete graph of this equation, f of x equals x cubed minus 3x, they want us to use the fact that the graph has at most 2 turning points. As we go through the course, we'll learn more about those turning points, but we can graph this as we go so we get an idea of what kind of a shape we're getting, and the hint that it has at most 2 turning points. So if I put in f of -3, that's going to be -3 cubed minus 3 times -3. So that's going to be a -27 plus 9. That'll be a -18. F of -2. We get this going. And if you want to go a little bit quicker on this, I can show you how to do this on your graphing calculator. Okay, now, and we're going to go for accuracy on our points. We're not just trying to imitate the shape as if you would put it into y equals. So let's go ahead and put in parentheses. I'll show you how to do this. -3, and we're going to cube that, and we're going to subtract 3 times -3, and whoops, I always make this mistake here, and I know that. If you notice when I made that mistake, I'd put a minus there, and it says syntax error. It means there's something wrong with the way you typed it in. You can either quit, or it has this option to go to the error. That's nice, because if you click that option to go to the error, it shows you, oh yeah, I used a minus instead of a negative. That's one of my famous errors I make a lot. So just know what kind of errors that you make so you can quickly correct them, quickly catch them and correct them. All right, so there's my -18 that I have in my table over there. Now we can just go back up, copy that expression, and change my -3s to -2s. So you don't have to type the whole thing over again, just overwrite. Oh, there's my -2 that I got. Let's go and do that again. We're going to put in a -1 there, and a -1 there, and I get a 2, a +2. Okay, and let's go back, arrow up twice, hit enter to copy that. We'll replace that 1 with a 0. You can, when you're over that negative sign, you can just hit the delete button. It'll take it out, and then when you type 0, it will overwrite the 1. So you get a 0 here. Okay, so you can let the calculator do the computation for you, and put a 1 in there, a 1 in here, and we've got a -2, and we've got, and copy that again, hit enter, and put in a 2, put in a 2, and get a +2, and do this again with copying that expression, replacing, oops, accidentally change screens, change that 2 to a 3, oops, change the 2 to a 3, and there we go, get 18. And look like we've got some symmetry going on in that table again, so you'll see it in the graph as we go. So -3, and we've got to go all the way up to 18 and all the way down to -18. So let's do by maybe 5s. This is a -5, -10, -15, -20, and at -3 we're down here at -18, at -2 we're at -2, at -1 here 5 and 10, 15, 20. So at -1, we're at 2. At 0, we're at 0. At 1, we're at -2. At 2, we're at 2. And at 3, we're at 18. And you can see that nice shape. There we go. There's 1 turn. There's 2 turns. Okay. And looks pretty good there. We see that we've got the 2 turning points. We have the y-intercept, but we do have 2 more x-intercepts. This is both a y and an x-intercept here. We need to make sure that we're picking up those x and y intercepts. So how would you do that? Well, you're going to make your y into a 0 to find your other x-intercepts. You're going to make the y equals 0 and figure out what the x value is when the y is 0. So 0 equals x cubed minus 3x. And we get an x and an x squared minus 3. So x equals 0, or x squared minus 3 equals 0. We've already got this one, so x is 0 when y is 0. We get the point 0, 0 from that, and that one's the one that we graphed. And this is going to be x squared equals 3. I'm going to take the square root of both sides, make sure I input the plus minus, and we'll get plus or minus square root of 3. Now you can put that on your calculator so that you can get a decimal approximation of it. It's about 1.7. Okay, so it's about 1.7 or negative 1.7. So here we go. Looks like we actually graphed it pretty decent. So that is a complete graph. You see the turning points. You see all 3 x-intercepts and the y-intercept. And this hints as to what the graph is doing off that window. So that's a complete graph. For example 3, we're graphing a complete graph with technology. So we kind of did that with technology here, but they are actually wanting us to use the grapher on the graphing calculator. So let's go here. Go to your y equals window, and you can put in the equation. Now your x variable is right here. You don't have to do anything with the alpha. Just use this for your independent variable. X with an exponent of 3, and you need to arrow right to get out of that exponent, minus 3 times x squared. Squared is used so much that they just make it its own button there. And minus 13. Okay. And they want us first off to graph this using a standard window. So what they're talking about there is the zoom setting. They're talking about the zoom setting. So let's go to zoom. Zoom standard is option 6. So you can scroll down to select 6, or you can just press 6. And the standard window makes your left bound -10, your right bound +10, your lower bound on the y-axis, your -10, and the upper is +10. That is a standard window. So there we go. That's the graph we're going to get. And it actually doesn't look very snazzy, does it? It's not the best representation of what's going on with that function. You can't really tell much of what's going on. So, but that's a standard window. Okay, now they want us to use this window. This looks a little discombobulated, but you'll get used to it. It's just directions to tell you what zoom settings that they want. Okay, and so we'll go into the window, and you see X-Men. There you go, x min. They want x min to be -10. It already is because that's what it was when we graphed in standard window. The x max is a +10. That's good. They want the y minimum to be a -25. So let's scroll down to that and put in a -25. And y maximum they want as a +10. It already is from when it was in standard window before, standard zoom. Another way that they will denote this is that they give you the x dimensions first and they give you the y dimensions, okay? Minimum and maximum on x and y, and you know that that's what they mean is for you to enter those bounds on the window. Now go ahead and hit graph, and nice graph. You can see there's 2 turning points on it, and let's go ahead and copy that there. Yep, it's a lot nicer view of what's going on than the graph that we had before. So this is what that graph looks like for that window. Which graph gives the better view? Obviously B. That's a complete graph. We could even take that graph and zoom out from there. Okay, zoom out. You can see it doesn't do anything else interesting. It has that one little up, down, back up point, place where we've got an inflection point, a little local maximum and a local minimum, but the rest of it's just going up, just going down. So that is a complete graph. Everything that is interesting on the graph is captured in that window. All right, example 4 is talking about cost benefit. All right, the cost of removing P% of the pollution from drinking water is given by this model. The cost is 5,350 times P over 100 minus P in dollars. They want us to use the restriction on P to determine the limitations on the horizontal axis values. So what is this restriction that they're talking about? What they're referring to is that we have P in the denominator here, okay? When we have a variable in the denominator, we're restricted on what values we can have, okay? We know that 100 minus P cannot be 0 because we can't divide by 0. You can show in your calculator if you just try to calculate something like 6 divided by 0, it's going to give you this error that you divided by 0. So we know we can't do that. That's the limitation that they're talking about. So P is the horizontal axis. The limitation on that horizontal axis is found by solving this restriction. So subtract 100 from both sides, so we know that P cannot equal 100. Okay, so we are going to have values of X. Well, it doesn't make sense to have negative amount of pollution. So obviously the lowest bound is going to be from 0. So your P minimum is going to be a 0, and the P maximum is going to be 100, and it actually cannot get to be equal to 100, but we'll put that as our window on the horizontal axis values. Now they want us to graph this function on this viewing window of 0 to 100 by 0 to 50,000. So just grab that graphing calculator. Again, go into y equals. You can clear out that function that you had before, or if, just to show you this. If you want to keep it, and use it later, you can just scroll over onto the equal sign and hit enter, and it turns that equation off, so it's not going to show up when you graph this other equation. So that's just a little tidbit there. We're going to put in 5,350x. Remember, x is our independent variable here. They're using p as the independent variable. It doesn't matter what you name it. It's an independent variable. And we're dividing that by 100 minus p. We're going to have to put that in parentheses. 100 minus p. So 100 minus x. So if we don't put the parentheses there, what we're actually doing is taking 5,350x, dividing it by 100, and then subtracting x from that whole quantity. So we don't want to do that. We want to make sure we're dividing by all of 100 minus x. Have to put it in parentheses. Let's go to our window, change the x min to 0, x max to 100. And we're going to, just by their direction, do a y min of 0 and a y max of 50,000. And just hit graph, and there we go. Okay, let me fix that. So we're going to save this graph. Okay. And so I know that I have it on this nice window. That's what it's going to look like. And we need to find the point on the graph that corresponds to a p equaling 90, and then we'll interpret the coordinates of this point. So every point on this graph is a it's a PC type of point. The P is the percent of pollution removed, and C is the cost in dollars of doing that pollution removal. Okay, so we are looking for the point on the graph that corresponds to P equals 90. In other words, the first spot will say 90, and then we've got to figure out what the y is that goes with that, or the c that goes with that. So we're looking at this. How can you figure something like that out? One thing you can do is hit trace, and then as you move, you see my x values are changing, but they're never right on an integer. But the trick is just hit trace and then put 90 in and hit enter. It will hop over to an x value of 90, okay? And then it'll read out what the y is, and that's 48,150. 48,150. Okay, so the difficult part comes to interpreting what the coordinate means. So go back to what we said over here. I encourage you to write this out like this so that you can interpret each of these in the context of the problem. What I mean is you could use this as maybe a conversation starter to somebody. You would never come up to somebody and say, the point 90, 48,150. Okay, they would kind of think, oh you're a little odd. Okay, and they, go find another bus stop to wait at, or something like that. What you want to say is what that point means in the context of the problem. Remember, the careers that you're going into, they want you to know the math and how to interpret what this data means for just the everyday person walking down the street. So what we say is something about P and something about C. So if we remove 90% of pollution from drinking water, then the cost is $48,150. Okay, so that sounds a lot more interesting and a lot more informational than just coming up to someone and saying 90, 48,150. If you came up to somebody and said, if we remove 90% of pollution from our drinking water, the costs would be 48,150. They might think it's, oh wow, that's an interesting fact. They might still think you're weird. Let's be serious about this, but it means more than just saying the point 90, 48,150. So that's what we mean by interpreting the coordinates of a point, or interpreting anything in this class, really. Okay, example 5 is about voting. Between 1950 and 2008, the percent of the voting population who voted in presidential elections during election years is given by f of x equals 0.0155x squared minus 1.213x plus 75.26, where x is the number of years from 1950. They have aligned the inputs to the year 1950. So if you use a input of x equaling 0, that represents the year 1950. If x equals 1, that represents the year 1951, and so on. So what are the values of x that correspond to the years 1960 and 2008? So for 1960, x would equal 10. Okay, so from the year 1960, we would let x equal 10 because 1960 is 10 years from 1950. And 2008, we would let x equal 58 because the year 2008 is 58 years after 1950. We are going to find f of 10 now and explain what it means. You can do this by substituting that in and getting the output. But if you look later in the problem, it says the model is accurate for 2008. Find the percent of the voting population who voted in the 2008 presidential election. So we're going to have to do this again. So if you want, you can plug it into the calculator. You could even put this into the graphing part of the calculator and trace to find the x value of 10 and the x value of 58 and see what the y readout is on that. It's up to you, whatever you like. I'm going to go ahead and just type it in. So we've got 0.0155. Oops, missing a 0, so I'm going to insert a 0. 0.0155 times 10 squared minus 1.21, oop, didn't get my point, 0.213 times the 10 plus 75.26. Okay, we hit enter and I get 64.68. So f of 10 equals 64.68. 64.68. Remember, this corresponds to a point of 10, 64.68. And what does it mean? What is the x? X is the number of years from 1950. So this is 1960. Then the percent of the voting population who voted in the presidential election is here. So it means in 1960, 64.68% of the voting population voted in the presidential election. Okay. Now, if this model is accurate for 2008, find the percent of the voting population who voted in the 2008 presidential election. We can do that quite easily. Just go up and copy that and replace the 10 with 58. 58 being 58 years after the year 1950. Okay, so we're going to hit enter. We get 57.048. Okay, so in 2008, 57 point, what was it? 048% of the voting population voted in the presidential election. And that's good. Okay, example 6 is talking about aging workers. The millions of Americans who are working full-time at selected ages from 20 to 65 can be modeled as a function of their age x, and this is the model y equals negative 0.000362 x cubed plus 0.0401 x squared minus 1.39 x plus 21.7. Use a viewing window with the x values representing the ages from 20 to 65. Okay, so they're telling you what values to use as the x min and the x max, and then graph that function with a graphing calculator. Now, you might not get this with the correct settings on the first try, but you can try, and I'll show you a little trick too. We'll go ahead and put this into the calculator again. Maybe you don't want to erase those previous functions you've put in. You can just turn them off. We'll go negative 0.000362 x cubed. Remember to arrow right to get out of the exponent, plus 0.0401 times x squared minus 1.39x plus 21.7. There we go. All right. So just double check after you've put these in to make sure you didn't have any typos. It's really important in this class to make sure that you've accurately entered everything. Your calculator will give you some kind of an answer based on what you've fed it. You want to make sure you fed it the right thing. Let's set our window now. We're going to set our window from 20 to 65. Okay, and this is supposed to be the number of millions of Americans that are working. So let's do a y minimum of 0, 60. Graph. Ooh, but it's kind of, I could lower this quite a bit. Let's try maybe a y maximum of 10. Graph that. Oh, that looks really nice. Okay, so you can trial and error it that way, or another thing that you can do is this nice feature that once you set the x minimum and x maximum, you go to the zoom and scroll down to zoom fit. what it does is it fits as much of the graph in as it can vertically based on the constraints that you've placed on X, the maximum and minimum X. So we'll do a zoom fit, and it fits it really nicely in there for you. So that's your nice graph. Okay, again, put that in here. And okay, so use that model to estimate the number of Americans age 55 and age 64 who are working full-time. Okay, so the number of Americans age 55 working full-time. Okay, so the thing that they gave you, that number of 55, you need to decide, is that an X or a Y? Well, the X is their age. X is the age, okay? So we've got these X, Y points. X is the age, and Y is the number in millions of Americans who are working. So we can go back into that graph. We can say, well, trace, and then type in 55 and hit enter. It will jump to that point, and then you can read off the Y. It's about 6.32, we'll say. Okay, is 6.32 million. All right, and then the number of Americans age 65 working full-time. Go back into the calculator. Again, trace, and we can hit your 65, and we get 1.36 about. So 1.36 million. All right. Well, I've given you a few options on how to find that material and those answers. Example 7 is a data table, U.S. adults with diabetes. So we have the number of U.S. adults with diabetes in thousands, projected to 2050, shown in the table. And we want to align the data so that X is the number of years after 2015. So let's do this. So make an X row. This is going to be 0, 5, 10, 15, 20, 25, 30, and 35. So we have our X values just written in above that table. And what is this L1 that they're talking about in the calculator? Well, if you go to stat here, we can edit the statistics that are in our calculator. We'll go ahead and hit stat and edit. So there you go. There's L1. So we're going to enter those values into L1. So it'd be 0. If you hit enter, it automatically advances to the next row. So 5, 10, 15, 20, 25, 30, 35, and double check, make sure that you didn't have any entry errors. Looks good. And then they want us to enter the number of millions of U.S. adults with diabetes in our L2. So that's L2, just arrow to the right to get to L2 and enter those. 37,300, 50,000, 59,500, 68,300, 76,200, 84,100, 91,700. You'd be surprised how many data entry errors there are in this course. You need to be careful as you are entering it, but also go back and make sure that you didn't leave something out. Like here, I've left out a 0. Okay. Like I said, the calculator will do something with the information that you fed it, so you need to make sure that you're feeding it the right information. And I double checked that. Okay, so we have that information entered, and here, there's our nice stat table. And then we're going to graph that in our stats. Okay, so there are a couple of ways to do this. Just go to, if you go to your y equals, first off, we don't want these other graphs to show up, so make sure that they're all turned off or you've deleted them. Okay, so what we can do is turn our plot on. The plot already defaults to list 1 and list 2. Okay, so you can do that. It's going to plot these points now that that is turned on. And then we go to zoom and zoom stat. You have to make sure that your plots are on first to be able to use zoom stat, but zoom stat will now make a nice window around those data points that you just entered into your stat editor. And that's what a scatter plot looks like. I have a video on YouTube also to help you with making scatter plots and those commands, so you want to go ahead and look that up, and I'll place the link for that into Blackboard for you as well. That's it. Go ahead and take a go at the homework.